Oh.
What do you think that number's there for?
I don't know. I'll mess it up.
Okay. So when we look at transformations, we have to look at it from vertex form. So you should have seen this before when we talked about the three forms of a quadratic. Okay. This is why we did completing the square. Because when you go from standard form to vertex form, you must complete the square. Okay. So, standard form. If I have a number on the inside of the parentheses with my x that is being squared, this means we have a horizontal translation. Put the scissors down. Okay. We have a horizontal translation. What everybody forgets is the fact that when it's inside the parentheses, it is opposite. So what I mean by that, if I have x plus h, if my h is positive, okay, so this is x minus h here. Whoops, x minus h. Okay, if I have x minus h, that means my h is positive. It's always opposite of what is there. So if it's minus h, your actual value is positive, which means we move to the right. If I have x plus h, that means my h is negative, and we're moving to the left. Okay. So when it's inside the parentheses, even when we get to the radicals unit, if it's underneath the square root, it's always opposite. So if you open this up, okay, your first graph is what we call your parent graph. Nothing is being done to it. X squared. Okay, so that means you've got a graph that looks like this. You've got a point here and a point that goes one to the right and one to the left. Your graph looks like this. And number 8, number 1, so you know what graph's going with what picture. Okay. Take a look at graph number 2. It says f of x equals x minus 3 quantity squared. So my number's on the inside of the parentheses, so that should automatically tell you my graph's moving to the left or to the right. If I have x minus 3, that means my h value is positive 3. So that means my graph moves 3 to the right. So all that happens here is each one of these dots moves 3 spaces to the right. So graph number 2 should look like this. Magical.
Miss Smith, can you give me a pencil? Please.
That's fine. Get off your foot. My pencil's there.
Well, I said you off your tush.
How'd you go 2 periods already without a pencil?
No, they take their pencils back.
I wish y'all would give me my pencils back so I'd stop.
No, she got it.
He thinks I'm scared. Okay. Take a look at your next one. We've got the quantity of x plus 2 squared. So what is my actual h value then? Negative 2, which means I'm moving to the left. So again, from your original, we move 2 spaces to the left. So my graph looks like this. And that's number 3.
No.
You should be able to look at any equation that I give you and tell me that moves 3 to the left and up by 2. That's reflected. That's our goal here. Also, looking back while you guys are doing this, do not forget, I have several upon several of you that need to come back and make up tests and quizzes that you were not here for. The end of the quarter is the 29th. You have until the 27th to make up whatever you're going to make up. Everything else stays a 0. So I need you to figure it out. Okay. The last one, x minus 1 squared. My h value is what? Positive 1, which means I'm moving to the right. And again, everything is off of this original graph, which was graph 1. So everything moves in terms of graph 1.
Oh, so it's what the heck? Is it 4? Oh, it's 4.
Okay.
Shanti said that she's
Yeah, that confuses my eyeballs.
Because there's so much on a page.
And I can't see.
So this was my original one that started at the origin.
Yeah.
Graph number 2, move 3 to the right. 1, 2, 3. Here's graph number 2.
Yeah.
Graph number 3, move 2 to the left. Again, from this original one at the origin, we moved 2 to the left.
Yeah.
And then back to the origin, the last one moved 1 to the right, so that's that one.
Yeah.
Everything is based off of that parent function. Okay. Move over to the other side now. We're talking vertical translation. So instead of moving left and right, this time we're moving
up and down.
up and down. Take a look at what value moves it up and down. It's your K value. Your K value is outside of the parentheses. So whatever your C value is, technically, okay? So the thing is with this one, though, if it's plus K, it moves it up. So it makes sense. It goes with it. It's not opposite like H is. And if it's minus K, we move down. So if you open this up, again, I've got that parent function. So I'm going to draw that in first. So your parent function is always starts at 0, 0. It goes up and to the right and up and to the left, one space over. So here's your parent function. That's number 1. Okay, graph number 2 is x squared plus 1. Your plus 1 is not in parentheses, so that should automatically tell you vertical translation. And if it's a plus 1, that means my K value is a positive 1. And if it's a positive 1, we shift up. So each one of these dots then is going to move up by 1.
Oh, that's kind of wrong right there.
It makes a burst.
It's kind of wrong, you know.
So that is graph number 2. What is wrong about it?
It makes a burger. You really like it.
Okay, number 3 is x squared minus 2. So what is my K value? Negative 2.
So we go down.
So we go down. Okay, the biggest thing is remembering if it's inside the parentheses, it's opposite. If it's outside, it's the same. So again, from this original picture, we're going down by 2.
Down by 2.
Down.
So your graph is here. Are you all right?
The sky is falling.
It's not because we could tell it was falling down.
Wow. The earth is flat.
Please stop.
Okay.
No, it's not.
No, it's not.
Number 4, x squared minus 4. What's my k value? -4, which means we're moving down. Okay. Again, from the original graph, from the origin, 1, 2, 3, 4. So this final graph is here. Is there a reason that y'all are talking about stuff that we are not covering right now?
Tell them you don't want to. Do you want your grade to continue to go down?
All right. So we slid left and right. We slid up and down. Now we need to blow up or get skinny. Okay. That's what your A value does for you. We like to call it fat norm and skinny norm. Norm stands for your normal graph, and it's either going to get fat or it's going to get skinny. So when your A value, the number outside of your x squared, is greater than 1, that means you're stretched vertically. If I'm stretching vertically, am I going to get skinny or fat? If I take a string, thank you. If I take a string and put it on the top of Stefan's head, and I say,
Your neck gonna get skinny.
okay, Stefan's gonna get skinny.
Like you're really wrong.
Miss Smith doesn't get skinny. She just stays. Okay, so if A is greater than 1, this is skinny norm.
Let's get it.
Okay, if your A value is between 0 and 1, we're not looking at negatives. We're looking at fractions. That means I've taken you and I've shoved you down to the ground. And you widen out and you get fat. So this is fat norm.
Why do you put the norm on it?
Norm stands for our normal graph and what you're doing to your normal graph. You were testing my abilities. All right. So as always, let's put our first graph up there. Again, you've got this at the origin and your regular norm. Yes. Your parent graph always starts at the origin, and you've got one dot to the right and up, and you've got one dot to the left and up in one space. Okay, so this is norm. Graph number 1 is norm. Okay. If I have 2x squared, my A value, is that less than 1 or greater than 1? Greater than 1. If it's greater than 1, that means we're stretching, which means we have skinny norm. So watch what happens. It's not shifting anywhere left and right. So we still start at the origin for this graph. Okay, skinny norm, however, instead of going up by 1 and to the right by 1, yes, sir. I mean, by all means, Stefan. I'm going to continue. So what you miss, you got to get caught up on. Take a pass with you. Take a pass with you. Okay, so skinny norm is not moving anywhere. It's just getting skinnier. So instead of going up 1 and to the right 1, now I'm going to go up 2 and to the right 1. Up 2 and to the left 1. So now my graph is skinnier. Okay. So if it was 3x squared, you would go up 3 to the right 1, up 3 to the left 1.
It makes it skinny.
It makes it skinny. And then down here, my last one, I've got 1/2. So my A value is less than 1. So we've got fat norm. Okay. This tells me how I'm going to move. So again, I'm starting at this origin. Okay, if it was 2, we went up 2 and over 1. Now it's 1/2. So I go up 1 and to the right by 2. Use this as your slope. So 1/2 goes up 1, to the right 2, and we also go up 1 and to the left 2. No, we haven't done that transformation yet. See how that one's gotten a lot fatter than the other one?
Yeah. It's like a tornado in a hurricane.
Tornado in a hurricane?
Because a tornado is so skinny.
They can be fat too, bro.
Is there a reason that you're eating in my classroom when you're not supposed to be?
Because she want to be a thingy on the ground. She want to get big. Put it up.
Okay, the last one we need to talk about is a reflection. When your A value is positive, it's an upward facing U. If my A value is negative, it becomes a downward facing U. Okay. So here's our last one, and we're done with notes for today.
No.
Yeah.
Yeah.
No.
Yeah.
Yes.
So here's norm.
Normal.
Okay. All I did in the first graph was change my x squared to a negative. So instead of being smiley norm, this is frowny norm. So instead of going up and to the right, I'm going down and to the right and down and to the left. So happy norm, sad norm.
It looks like I forgot what the animal is called. A what? No.
He said no.
I forgot.
Okay, take a look at number 3. All I'm doing is x plus 1 quantity squared. So what is happening to my graph? X plus 1 is inside the parentheses. If it's inside the parentheses, which way does it move my graph?
To the left.
To the left. Okay, remember, inside the parentheses. Think about it this way. It's inside with the x, so it should move in the direction of your x-axis, which means it should move left or right. And because it's plus 1, that means my h value is actually -1, which moves it to the left. So my graph would look like this.
We're going up.
And it's not a negative, so it's an upward. It's a happy norm.
I'm happy.
I'm happy. Whoa.
And my last one, it's a negative. So yes, I'm still moving to the left. My h is still a -1. So I have to move to the left. But now I've got this negative. So instead of being happy norm 1 space to the left,
You're going to be sad.
it's sad norm 1 space to the left.
Oh.
So instead of going up and to the right, once I move to the left, I go down. And we make sad norm.